Hello again. So today what I'm going to do in this video is I'm going to try to introduce motor control. I'm going to be showing some code that you haven't seen before. If you're a programmer, awesome, you'll understand it. If not, don't worry. I'm going to go back over the code and introduce the concepts. But right now I just want to demonstrate how you get these motors to work so you can start building your projects. And then we'll worry about the details going forward. But so this particular video is going to be about pulse width controlled motors. So that's going to be things like your typical hobby servo, okay, like this one. It's going to be servos like this, which are modified. This is able to turn 300, well, I don't want to turn it, but it'll turn 360 degrees. This one only turns 90 degrees. It's unmodified. It also includes devices like this, which are speed controllers, and this one is for hobby cars. So it has a single cable coming from it with 3 wires, 1 power, 1 ground, and 1 signal, just like the servos did. And even these very large, beefier devices like this one, which are able to handle an enormous load, but ultimately it's still controlled by this one cable that has a signal, a power, and a ground. Okay, so it's going to take a pulse width from a single pin. So what does that actually mean? The industry standard for pulse width, sorry about my camera, I bumped, there we go. The industry standard for this is a pulse of 1 to 2 milliseconds with a 20 millisecond delay. So if I take, for example, looking down on a servo, if I send a high pulse of 1 millisecond and then a 20 millisecond delay, and then, for example, we'll say that's 20 milliseconds, and then send another pulse of 1 millisecond, so he's sending a pulse train, okay? What'll happen, depending on the servo, is it's going to cause that servo to move to its maximum position, okay, over here. So the servo might end up, for example, in this position. All right. If I send a pulse of 2 milliseconds with a 20 millisecond delay, it'll then, I'm going to mark this as 1 millisecond. Again, this depends on your servo. It's going to cause your servo to move to its maximum position over here at the 2 millisecond. Okay? And if I send one in between, I should have got myself a bigger piece of paper. If I send one at 1.5 milliseconds, okay, 1.5 milliseconds, it'll send it to the center position. All right? Now, another interesting thing about this is if I'm at the 2 millisecond pulse and I switch it to 1 millisecond, okay, so I was pulsing at 1 and then I start pulsing at 2, it's going to go as fast as it possibly can to get over to the 1 millisecond position. Okay, it knows it's a long ways away. There's digital circuitry, electronic circuitry inside the servo that says, whoa, I couldn't possibly be further from where I need to be, I better boogie, and it goes as quick as it can. Okay? Let's say, for example, I'm over here at around 1.1 milliseconds, and I change it to a 1 millisecond pulse. Well, now it's going to say, I'm already pretty close, I better gingerly move there, and it slowly moves closer to the 1 millisecond pulse from the 1.1. And then, of course, if I send a 1.5, it goes to the 0 position. Now this is all referring to regular servos, unmodified servos, and I'm going to show you, probably maybe even hear one going. You can see my code over to the side. Modified servos, what's happened is the sensor that has been placed inside the servo has essentially been broken, and it's fixed in such a way that the servo always thinks that it is at the 1.5 millisecond pulse or 90 degree position. So if I send a 2 millisecond pulse, it realizes that it thinks it's really far away, So it goes as quick as it can to the 2 millisecond direction. Okay? Likewise, if I send a 1 millisecond pulse, it goes as quick as it can to the 1 millisecond direction. If it's close, let's say I send a 1.6 or a 1.4, well, it thinks it's already close, so it moves slowly clockwise or counterclockwise trying to get there. Okay? So if we look at what I've got right here, all right, this is an unmodified servo, and it's currently hooked up to my pin 0. I have the signal over here. Okay, the ground is on the outer edge. And if we look at the code, okay, I've created a couple of variables here, well, I'll explain that a little bit later, but I created one that's servo 0 because I'm hooking it up to pin 0. All right, I have my standard sort of introductory stuff here. I did have to set servo 0 to output. And let's go to the loop. Now this is where, if you know code, awesome. If you don't, please don't worry about it. I'll explain it in greater detail later, but I'm going to introduce the for loop here. So what's going to happen in this loop here is it's going to start off at 1,000. It's going to shoot to get to 2,000, and it's going to do it by incrementing by 5. So it goes 1,000, it goes 1,005, 1,010, 1,015, 1,020, all the way up to 2,000. It, right here on this line, it sets the pin high. Okay? For how long? This is microseconds, so it sits it high for 1 to 2,000 microseconds, which is, going back to our diagram, is 1 to 2 milliseconds. Then it turns it off, sets it low, and then it waits 20 milliseconds. So once again, what's it doing? It's sending it high, 1 millisecond, or 1,000 microseconds, waits, and then sends it, well, then it's in a loop, and in this particular case, it's going to increment it by 5 every single time it does the loop. Okay? So it's going to get wider and wider and wider. And lo and behold, we see that the motor is moving from left to right. Now notice you don't see any change in speed because it always thinks it's very close. Okay, because the change between 1,000 and 1,005 is very slight. So it thinks it's pretty close, so it moves at a pretty constant rate from the left to the right. Okay, once it completes it, goes up to 2,000. I have written another little block of code here that makes it go down again. So it goes up, it goes down, it goes up, it goes down. Repeat, repeat, repeat. Now I'm going to further demonstrate this, and I'll show you the code, but for heaven's sakes, if you're not, oops, I set my keyboard down here. If you're not code savvy, don't become overwhelmed, but I think it's a nice demonstration. I'm going to show it being graphed. And okay. So here again, you can see this moving line is the pulse. Oh, I should make it down here so you can actually see. Okay. And you can see as it crosses the 1.5 millisecond area, it hits center, and then it goes the other direction. Okay. Now this whole thing becomes a lot more interesting when you hook up a modified servo. Remember, a modified servo thinks that it is always at 1.5 milliseconds. Put that in a position where you can see it. I'm going to make this a little small. I can't make it smaller. Sorry, I'm going to try to rearrange my windows a little bit. Okay. So you can see it speeds up. it comes to a stop here and then switches directions. Okay? Stop, switches directions. It's moving pretty slowly in this band, either clockwise or counterclockwise. Alright? So hopefully that kind of explains a little bit about motor control. For those of you who are curious, I'm going to show you how I did this print position. You can shut yourself down if you don't want to try to pick up some coding, but the print position, what you see actually happening in my graph here is I'm taking those values 1 to 2000 and I'm simply printing a whole lot of dead spaces, and then I print the star. Notice because of 2000 blank spaces goes off a page, I divided it by 10. Okay, so now it actually goes between well, actually, first thing I did, I'm sorry, is subtract 1,000, because if not, we would have had to go 1,000 blank spaces before we even had a picture at all. Okay, so by subtracting 1,000, I moved everything over to the left. Then, because the page is too long, you know, 1,000 spaces between 1,000 and 2,000, it still was not going to fit on a computer screen. I divided all of that by 10. Then it prints blank spaces, then the star. To make the graph part, I start off by printing 1,000 microseconds. And in this case, I had to split it because I want to have my center line in here. So I did a little fudging around with the numbers because this actually takes 6 characters. I actually moved it over 6 characters. I still subtracted 1,000 so it would fit at the far left of the screen. Still divided it by 10. Blank spaces, then the dash, and then again on the other side, because I need to put some spaces before I put into 2000. Alright? And I'll explain all of this and how to make tabs and everything else in a future video, but hopefully this was informative as to how the servos work and pulse with, and I will see you all again shortly.